Calculus of polar equations. Yes, we are going to do a lot of calculus here. This where we are is based on both integration and what? Differentiation. But don't worry, I'll give you the techniques, the things that you'll be meeting, and how you can be able to integrate it and go. Alright? So before that, let's look at the area bound by a polar curves. The area bound by the polar curves, and that is what is going to bring the integration in. Because when we talk of integration, we are talking of what? Area. And when we talk of differentiation, we are talking of what? Slope. So that is what it will be bringing in. Alright, so now, let's say that we have a function r is equal to f theta. That means that a function in terms of what? Theta, yes. The polar equations are all r, or a function of r in terms of what? Theta. That's what we have here. Alright, so we are going to base on that. Then let's say that this is our shaded region. Then that means that you take the integration, we take this as our lower limit, then we take this as our upper limit. So the area will be the integral from lower limit to what? Upper limit. Now you can see that this is like a sector. It's a sector. So it's like you taking the area of what? A sector. And you know area of a sector is half r square what? Theta. So having this is going to be integral from the lower limit of alpha to lower limit of what? Beta, which is half r squared d theta. So we are going to integrate. This is a function of r in terms of what? Theta. So you integrate it as respect to what? Theta. And the same as the function in terms of what? Theta being squared, then that's what we are going to have. Alright, so we are first going to look at area bounded by a polar curve. This is just one polar curve. We have when the area is bounded by two polar curves. You'll be looking at it. But before we even get to everything, let me give you the techniques that you need here to be able to take your integration and differentiation and all that. Alright, love you. Alright, so what you need to know. First of all, let me talk about trig identities. Trig identities here. In fact, your trig identity should be good. You'll be meeting some trig identities like 1. Okay? Cos square theta plus sine square theta is equal to what? 1. Don't forget it. 2. We will be meeting something like cos square theta minus sine square theta. If here is plus, it's 1. If here is minus, it's what? That's from double angle cos 2 theta. You need these two. Alright? You also have to know that sine theta over cos theta is going to be tan theta. And the reciprocal of it is the cot theta. Alright, so you need to know that. It's very necessary. It's very necessary if you know that. Alright, but don't forget that here is squaring. If it's not squaring, leave it. Alright, so that's what you have to know. Again, you have to also know something about the half angles. The half angles. It's very necessary. Alright, so the half angles is like if you have 1 cos theta, if you have something like cos square theta. Okay, so this is going to be, what we have here is going to be half 1 plus cos 2 theta. The idea is that whatever you have here, you multiply by 2. Okay? So you see that here is something like 1. Or let me use n. Let me use n. N theta. So since the n here is 1, here and here is something like 2n theta. Let me generalize it. So cos square n theta. The half angle here is that you multiply this. That means that if you meet cos square theta, it means that the n here is what? 1. That is coefficient. So the n here is what? 1. So here is going to be 1 plus cos. Then the n is 1, so 2 theta. So that's what this is going to give you. I hope it's clear. Alright. So if you meet cos square half theta, that means the n here is what? Half. Good. So here is going to be 1 over 2. 1 over 2, 1 plus cos. So multiply here by 2, you get 1, so cos theta. So that's what it's going to be. Okay? Alright. Another thing I also add for you here is that anytime you are to integrate something like this, change the function of this to this. Please, I beg you, listen well. If you are to integrate something like this, this is the integral function you want to integrate. And it's the same as this. You taking integration of this one will be something tedious for you. So what you have to do is that you change the function, then you come and integrate this. So to integrate this is the same as to integrate this. To integrate this is the same as to integrate this. Alright? Okay. Let's talk something about the sign. The sign. So 2. How will I take note? Sine square n theta. So what this one to mean is that half of 1 minus cos n theta. That's what this one to is going to be. So to have sine square 3 theta or theta, what is here is what? 1. So n is 1. So half. Remember, you know the same as the first, the cos. If here is cos, here will be cos, alright, but here will be plus. If it's sine, here will be cos, but here will be what? Minus. Don't forget it. So here, 1 minus cos, multiply the 1 by 2, you get what? 2 theta. So that's, 2n theta. So that's how this one too is going to be. So to have sine square 2 theta, this is going to be half 1 minus cos 4 theta, because we know the n here is what? 2. So multiply by that to get what? 4. So that's how it's going to be. If here is half, here you are 2. In the same way, to integrate what is here, is the same as you integrating this. So anytime you meet something that you are to integrate this, change this to this and integrate, and you go your way. Alright? Good. So, after this, then, what you have to know again is that if you integrate integration, so here, if you integrate this, you get this 2. If you integrate cos theta, the theta, you are going to get sine theta. Sine theta. Alright, so that's what I want to give you. In general, we add plus C, we add plus C. But as far as course is concerned, you are going to deal with boundaries. That is the lower limit and the upper limit. So this C will not count. So just know that if you integrate this, you get this. If you integrate this, you get this. All right. 3. If you integrate a constant, you get what? If you integrate a constant like k d theta, if you differentiate with respect to the theta, that means that here is going to be k theta. Here, when you integrate, you will not get 0. In differentiation of constant, that you get 0. But in integration, you will not get 0. You add the operator to it, and the theta is the operator. So, for example, to integrate 2 the theta, you get 2 theta. I hope you guys see that. Alright, that's what you have to know. Again, another technique that you have to also know is that I want to help you so that when we get there, you will not suffer. To integrate something like sine 2 theta, the theta, you know that if you integrate sine, you get what? Negative cos. But here, it's not just sine theta, it's sine 2 theta. It's sine 2 theta. So what you do is that you let u be equal to 2 theta. Then you differentiate this du as respect to what? Theta. And you are going to get what? So differentiate this, you get 2. Alright? Good. So then after that, make theta the subject. So you get the theta is equal to. So when you make theta the subject, you get what? Du over what? 2. I want to show something to you. So here, you are going to do the substitution back to this. Okay? So integral of sine, and the whole of it is what? U. Or you can see that. And the theta here is what you are making to be a subject here, which is du over 2. So now you can see that there is a constant among here that is half. Bring that half out. It's like it's integral of what? Sine u du. So you can now see it clearly that here you can integrate, you don't know how to integrate sine 2 theta, but after doing the substitution, after setting here to be u and doing the substitution, you can now see clearly that half integrate sine u, you get what? Negative cos u. And you go your way. Just like that. Yes. Plus C. You go your way. But you know U is what? 2 theta. So negative half cos 2 theta plus C. So that's going to be beautiful. Don't forget it, because for instance, if you have to integrate this and you can't integrate, so you change the function to be this. Know that. Let's try one and see. For instance, you have to integrate cos square 2 theta, the theta. So you can see it's half angle. The moment you see the square here, know that it's dealing with what? Half angle. So you change this function, the whole of this function. So you say but, all we are watching, but cos square 2 theta is equal to half 1 plus, the thing is cos 2n, and the n is what? 2. So here we come 4 theta. So that means that to integrate this, you change it to half 1 plus cos, I hope you are watching, 4 theta d theta. Now clearly, to integrate this is easy because you just multiply this by, or you can even bring this one outside so that the half will be here. You have 1 plus cos 4 theta d theta, right? So now, I just want to help you so that when we get there, we will not waste time. Alright, so we've got time left. Alright, so here, have integral of. Now, integrate, so here, you can plug this one here and integrate 1. Bring theta. You can split it, okay? Plus integral of cos 4 theta. Then d theta. How are we going to see that? So half integrate 1, you get what? Theta. Plus integrate this. What are you going to get? Alright, I'll give you a technique, okay? Don't worry. So to integrate this, you go by that process, by setting the inside to be u and all that. So when you do that, you are going to get sine. I'm going to write it just once, and I'll tell you the technique. So integrate cos, you get what? Sine 4 theta over 4. Alright. So this is going to be half theta plus sine 4 theta. All this over 4 plus c. Let's check if the integral of this one is true. So that you see the technique. It's just simple. Watch. You see that if you have integral of cos 4 theta d theta, u is equal to 4 theta, right? So du d theta will be, differentiate this, you get 4. So you will make d theta the subject, which will be d theta is equal to du over 4. Right? So you go and do the substitution. And when you go and do the substitution, you are going to get something like this. Cos, the whole of this is what? U. And the theta here is du over what? 4. So you see that you bring 1 over 4 out. Is that also? Then it will be left cos u du. Beautiful. So now when you integrate cos, you get what? Sine u. So it will be 1 over 4 sine u. And you know that u is 4 theta from here. So straight away, it's the same as, oh I love maths. It's the same as integrate this, you get sine. Bring the inside over the constant there, over that. That is all. See you for the next video.